guys, Ms. Michelson here. Today I'm filming a video going over our circles review that's posted for March 25th, the day we have our sub. So we want to make sure we're getting that open. We're working on it. I'm filming this video in case you need any help on any of your problems. I've got my assignment pulled up and I am ready to go. So the first question is asking me to find the center and the radius of my circle defined by this equation right here. We might have to reference our notes to remember this formula, but the equation of a circle is x minus h squared plus y minus k squared equals r squared. So we've got kind of like three pieces or three variables in our equation that are the center and the radius. So I'm looking for what numbers are in those spots, and I see a 1, I see a 5, and I see a 9. So those are the three numbers I'm going to be dealing with. So the 1 is in the spot of the H. So the center coordinate of my circle starts with a -1. And that's a little bit weird, but we got to remember to change the signs there. We've got a -1. The K value of my center is the second number here, and it's a -5. So I'm going to change that to a +5, and that's my center, those two numbers right there. Now my radius, this is the one that's a little bit weird. It's the number that's all by itself. And we got to remember that that box represents r squared. R squared equals 9. So our radius isn't just 9. We have to get r by itself, which means we have to take the square root of it. The square root of 9, though, is 3. So the radius of my problem here is 3. And we are moving right along. My next question, I think, is also about circles. So this one, we're going to move a little bit backwards versus what we just did. This time we want to write the equation of the circle. Still, I think it would be helpful to have this equation written down for us. But now I got to figure out what those pieces of information are, the H and the K and the R, all by looking at this graph right over here. So the center of my graph is this point right here, P. I notice it's at a Y value of 5, and it's at an X value of -3. So those are the numbers I'm going to plug in for H and K. But just remember, like we did in the last one, they have to switch signs. So if this is a -3, it's going to turn into a +3. And the 5 is positive, so it's going to turn into a -5. And then the last thing that we can identify here, I didn't actually really mean to draw that, but this line right here is also what we would consider the radius because it starts at the center to the outer edge of the circle. And if we count the distance between those 2 points, it's 3 boxes. So the radius is equal to 3, but we got to remember to square it. So 3 squared is not what I'm going to write. I'm just going to say it equals 9. And then this is just like a little bit tedious, but we have to type this into that box. X plus 3 squared plus y minus 5 squared equals 9 is my final answer. All right. Question number 3. What is the center and the radius of the circle? One last problem. I would challenge you to see if you could do this one on your own now. I see this -1 right here, which lets me know I have a +1 in my center. And I don't see anything that I'm adding or subtracting from y. So that one's a little tricky. It's a 0. And then last thing is the radius of our circle is this last number right here, the 36, but I got to take the square root of it. The square root of 36 is 6. And well done. I think that's my last question about the equations of circles. Now we get into our fun questions about the arc measures, the degrees on the outside of our circle. So what we're going to take a look, try to find in our picture what dB is. That would be this arc measure right here. And we want to figure this out by using some of the other pieces of our puzzle. So this measures 129. So I know this arc over here is 129. This measure over here doesn't have a number, but it has this little box, which lets me know that that's 90 degrees. And then I don't really know anything about this part right over here. So my strategy to find this green section, that's my question mark, is by looking for a semicircle. And I see that I have a straight line cutting through here, which means this semicircle, or that straight line, has a degree measure of 180. So if the total is 180 and one little section of it is 90, then that must mean when we subtract those two numbers, our final answer is 90 degrees. And I think our next problem is going to be similar, maybe a similar diagram. So we're still dealing with angle measures, and now we've got kind of a little bit more of a complicated problem. But the first thing that I always like to start off with is, what am I trying to find? I'm going from P to S to U. So I have to know all of this right in here. So I'm going to go through and see what I do know. I know this is 90. I know this is 37. And I know this and this are congruent, so this must be 37 as well. And then I have this and this telling me that those two are the same, but I don't know what they are. And that's actually the last piece of my puzzle. If I know what I've put my red question marks by, then I can figure out what my final answer is. The only thing that we haven't used is this 132, and I know that that is this part of my puzzle right over here. So similar to our last strategy that we had, I'm going to look to see if I can find a semicircle in here. Anything that looks like a straight line. And I don't think I have any. They like kind of look straight, but then bent at some point. So I don't have any semicircles. But I do have one other strategy that I can use here. This is a question mark. I'm going to call it X. This is a question mark. I'm going to call this one X. And now I can use my whole circle that I know is 360 degrees, and I'm going to subtract everything that I know. I'm going to subtract 37. I'm going to subtract it twice, actually, and 90 and 132. I've got my calculator sitting next to me, so I'm just going to type all of this in. And I get 64 degrees. So what this 64 represents is the degree measure split between these two angles. But because we know that they're the same, I'm just going to divide it by 2. And I'm going to get 32 for each of these. All right. Now, the very last thing that we want to do is just add up everything that we found here in green. And when we do that, we get 228. 228. There are a couple other ways that you can solve this problem. So if you use a different strategy, that's okay. That's just the first way that came to my mind. All right. My next question is our tangent theorem. So this is what we reviewed, or we did on Monday of this week. And the big thing that we want to know is when we have tangent theorems, we want to figure out whether or not we have right triangles. And when we have right triangles, we can use our Pythagorean theorem, a squared plus b squared equals c squared. So this tells me that AC is 13 and BC is 10. We want to find the length of the radius. I'm going to call that x, and that's AB. So I'm going to use the Pythagorean theorem because I see that I have a right triangle to solve for the length of my radius here. The diagonal length, or the slanted side, is always C, so I'm going to plug it in here. I'm going to call x B, and then A I'm going to plug in as 10. And now I'm going to solve for x. 10 squared is 100. 13 squared is 169. I'm going to subtract 100 from both sides. X squared equals 69. And then I take the square root. It tells me to round to the nearest tenth, which is 1 decimal place. I'm going to type this into my calculator. the square root of 69 is 8.3. You probably can't see that, but your numbers and your problem are going to be different from mine anyway. I accidentally put a little apostrophe. 8.3. All right, the other tangent theorem that we had was when we had lines that intersected on the outside of our circle. Our tangent theorem told us that they were congruent to each other. So congruent means we set them equal. And now we just have a beautiful, lovely little equation that we can solve. If you like to draw this line, that could be helpful. The first thing that I see as a problem is that I have an x on both sides of my line. So I'm going to subtract 6x from both sides. And I'm going to get 5x minus 40 equals 5. Now my whole goal is to get this x by itself. So I'm going to add 40 to both sides. 5x equals 45. And then I want to get x by itself, get rid of this 5 by dividing by 5. 45 divided by 5 is 9. My answer here is 9. All right, one last problem with our tangent theorems, I think, if I remember correctly. This one's very similar, so again, you maybe try this one on your own to see if you got it now. I've got two tangent lines that intersect on the outside of our circle. That lets us know that these two values are equivalent. They are a little tricky here because they're asking us to find HJ, so we'll come back to that in the end. But the first thing I gotta do is set my two equations equal. I'm gonna solve for x. And this one is a little weird. Typically what I would tell you all to do is to move the smaller one to the other side of the equation. But that cancels out. And what am I left with over here? Nothing. So I'm going to put a 0 there. And then I'm going to have a minus 4. 4x minus 3 is just 1x. And now, hopefully we can see we can solve this for x just by adding 4 to this side of my equation. X equals 4. But notice that my answer or my question is not asking me to find x. It's asking me to find the length of hj right here. So I'm going to have to plug it into this equation because hj is a radius and h to g is also a radius, and all of the radiuses are the same. So I'm going to take this x and I'm going to plug it in. 4 plus 3 equals 7 is my final answer. All right, moving right along, we've got another Pythagorean theorem question. I lied to you all. There was one more tangent theorem problem. This one wants us to determine whether or not it is tangent. So our actual question we're asking, is it a right triangle? And the way we're going to verify that is by doing a squared plus b squared equals c squared. We want to see if that's true. So the diagonal, the slanted line, or the biggest number is always c. That's 13 squared. My 5 and 12, I'm going to plug in for b and a. 5 squared is 25 plus 12 squared is 169. 13 squared is 169, which is true. So is the line tangent? Our answer is yes. Okay, and now we're into our last section, which was our chords theorem. We learned this on Wednesday. These ones are a little bit tricky if we don't know how we need to solve them. If we do know how to solve them, if we're really comfortable with the Pythagorean theorem, then all is well in the world. So again, our strategy is just to use the Pythagorean theorem because we've got a beautiful, lovely right triangle in my picture. So let's go ahead and plug in our numbers. The diagonal line is always c. Another way you can think about this is that the radius is always c. So that comes in handy kind of in the future. A and B doesn't matter where that 2 goes, so I'm just going to plug it in for A. And then I'm going to leave B alone. 2 squared is 4, plus b squared equals 14 squared is 196. I should have known that. 196. I'm going to subtract 4 from both sides. B squared equals 192. And then lastly, I'm going to take the square root. The square root of 192 is 13.856. Now, let's be careful of what this b represents. Remember that it's just this side of my triangle. But x represents the whole thing. So I got to take my answer and I've got to double it. I've got to multiply it by 2 to find the length of that whole value x. So I've got that radical in my calculator and I'm just going to hit times 2. And my answer is 27.7. All right. Our next two are very similar, except for this one doesn't give ourselves a picture. So we're going to have to draw it. I'm going to start with the center of my circle. A chord of a circle is 42 centimeters long. Boop. 42. It is 20 centimeters away from the center. Boop. We know that these are right angles. What is the radius of the circle? I'm going to draw that in myself. And now we can see I've made a beautiful, lovely right triangle where we can use a squared plus b squared equals c squared to solve. Now this is where it's helpful to know that the radius is always c. So that's where I'm going to plug in my x. X squared. A, I'm going to say is 20. B, I'm going to say is 42. And I like this problem because now I can just type this whole thing into my calculator. This is what I'm typing in. 20 squared plus 42 squared is 2,164 equals x squared. And then I'm going to take the square root to get x all by itself. And what I get there is 46.5. I just realized I did the problem wrong. But I'll show you wrong. 46.5 is not the correct answer. And I made a really easy mistake. Really easy mistake to make. Maybe you caught it in the video when you were watching me. This number right here should not be 42. Because 42 represents this entire length right here. But my triangle is just from here to here. So what do I have to do with that 42? I've got to divide it by 2. It's going to give me 21. I really should have added 21 squared there. So, easy thing to correct in my calculator. Just type my new numbers in. I get 841. I got to take the square root of it though. And the square root of 841 is 29. And that's my final answer. Okay, one last problem. I'll try not to mess it up. They do give us our picture this time, which is nice. We want to find the value of x. The whole problem, though, is that I do not see a right triangle. And so I'm going to move this radius and create a right triangle over here. And I know that this length is 35. Now, sometimes I think it's helpful to redraw our picture. 35, this is x. And now we're not going to fall into the same trap as we did last time. This is the same exact number. I'm going to divide this by 2 to get 21. Now, we've got a squared plus b squared equals c squared. I'm going to plug in all my values. 35 is my radius, so it goes in for c. A squared, I'm going to leave alone. B squared, I'm going to say 21. Something you can do is I can subtract this whole value right here so that what I type into my calculator is just 35 squared minus 21 squared. think some of us have picked up on that trick. I'm just going to subtract them. 35 squared minus 21 squared is 748. A squared equals 7. I meant 84. Yeah. And then the last thing we got to do is just take the square root. A equals 28 this time, similar to our last problem. A equals 28. And that's the last question on our review. We can go ahead and submit our work. Remember, you can do the assignment as many times as you like to get a score that you want, and you are better for it to repeat those problems. And this is helping you in the long run. And I hope you all have a great spring break and be safe. And I will see you all when we come back to school.